This video is the tutorial for the SPSS Survival Manual homework for Chapter 16 on nonparametric statistics. Now, in this tutorial, I'm only going to be covering what we're doing, what you're being asked to do in the homework itself, which is a chi-square goodness of fit test, and then a crosstabs analysis or chi-square test for independence. There are many other kinds of nonparametric tests that are described in your chapter. We are only going to work in homework with these two because in my experience, these are the two that you're the most likely to run into when you do your senior research, and will be sufficient for your experiences as an undergraduate researcher. Before we get started, just a couple of words about what nonparametric statistics are and what they're used for. As Pallant describes for you, the distinction between parametric and nonparametric starts with the word parametric. Parametric tests like t-tests and ANOVAs, you're going to be making some assumptions about the population from which you pulled your particular sample. And basically we're making assumptions like the sample is normally distributed on the variables of interest, things like that. And you're more likely to be able to count on those assumptions if you have a sufficiently large sample, if you've done a good job of sampling across the various components of your population and so on. But those assumptions are pretty important. You know, when statisticians, mathematicians create these statistical tests, they do make assumptions about the nature of the data that you are going to use the test for. That's why they're called assumptions. And we're not supposed to violate those assumptions when we use those statistics. Non-parametric techniques aren't quite as stringent in terms of their requirements of things like normality or other kinds of hoops that you would need to jump through before you can draw conclusions based on the tests that you run. So they're not making the same kinds of assumptions about the underlying population or its distribution. There are disadvantages though, since you're not making those kinds of assumptions, you have to kind of build in some protections. That means they're less sensitive to actual patterns or associations between variables, for example. But given some of the disadvantages of nonparametric tests, you might be wondering, well, why would you use them? You might need to use nonparametric tests if the data that you're dealing with is strictly nominal or categorical, or it's ordinal, meaning it's rank ordered. If that's the data that you have, then you're going to need to use a nonparametric statistic in order to look for associations or patterns that are interpretable. Non-para tests can also be helpful if you've got a very small sample, or if you know that you have, say, skewed data, which means that you've violated some of the basic assumptions of that are required for parametric tests. So you would use a non-parametric alternative. Now you may remember in last week's homework, or maybe it was 2 weeks ago, I'm starting to lose track, where you were asked, choose the statistic, and there's a whole section in your chapter on, how to choose the statistic, and you were asked to name non-parametric alternatives. Well, that's the reason we do that, is so that if you find that your data actually violates the underlying parametric assumptions, you then would need to switch to using a non-parametric test if one is available to you. Now, as I said, what we're going to do in homework is we're just going to restrict ourselves to two different kinds of tests. One is called a goodness of fit test, a chi-square test for goodness of fit, which is a test where you're taking your sample data and you want to know if the differences in categorical data on one variable if what you see in your sample matches or doesn't match, i.e. isn't a good fit for the population distribution, if that population data is known. So for instance, if you know that in your culture, in say the United States, what is the percentage of people in the United States who smoke? And if you know that there's a known percentage, then you can do a goodness of fit test to determine whether a sample that you pulled, say the students of Mount Union, actually match that underlying population. So in the homework, what I've asked you to do is to just repeat the example that's done for you in the chapter, because there they provide you with the parameter values such that you could do the goodness of fit test. So following the directions on page 223 to do a goodness of fit test, and you can see I've already got survey.save open. I'm going to go to Analyze and all the way down to non-parametric tests and over to Legacy Dialogues and then up to chi-square. And then I'm only going to choose my one variable, do you smoke? And I'm going to put that over as my test variable. Under the expected values section, you want to then click on the values option. And as I said, this test relies on you having access to actual population values, expectations. So we want to set the what is the percentage of people who correspond to option 1. In this data set, 1 is coded as a smoker. So what percentage in this case it's Australian data, what percentage of the adult population in Australia that smokes? About 20%. So you're going to enter in there 0.2 and then you click add. Then we want to know what's the percentage who are likely to select option 2, which is non-smoker. And in Australia, at the time the data was collected, about 80% of people are non-smokers. So 0.8. You put that in as your second expected value. So based on the population numbers, this is what we would expect of our sample. And the goal is, and you could ask, why would a researcher run this test on their data? Well, you might want to know, does my sample that I pulled with this question, do they fit with the national kind of statistics on the level of the baseline level of smoking? And what you would hope, you could hypothesize, yeah, the sample will be about the same as the national population. Okay, then we're done and we're ready to click OK. Now what you should see when you turn the page to 224 in your text, you should see the exact same numbers that you got there. And what you see first here is a frequency table. So you have observed values, expected values, and residual values in this table. And the observed values, you have 85 smokers, 351 non-smokers. Those are your frequencies. Then you have your chi-square test, and the asterisk indicates that the test was non-significant. So, and this would be asymp significance would be the p-value on the test. Now what I've asked you to do, and you're given a nice, in the gray box at the bottom of the page on 224, you're given this written description of how you would write up in a results section the results of this test. And what I've asked you to do in homework is to, in your own words, write a similar sentence. So for example, you could say that the chi-square goodness of fit test revealed that the proportion of smokers, which is 19.5 in the current sample was not significantly different from the percentage expected, which was 20% based on previous research. And then you give this statistical statement. The slanted, interesting looking X is the Greek for chi, and with the superscript 2 for chi squared. The 1 here in the statement is as you're reading in your text, the 1 represents the degrees of freedom. That's this 1 right here. And then the N is 436, the total N. And the value of the statistic is rounded up to 0.07 is the chi-squared value. And then the p-value is 0.79. And that is non-significant because you would have to be less than 0.05 in order to be significant. So in this case, basically what the researcher can say is that the distribution of, or the categorical distinction between smokers and non-smokers in this sample is equivalent to the distribution in the population at large. So roughly 20% who are smokers, slightly less than that, and 80% or more who are non-smokers. Now in the second question, I've asked you to work with the instructions on 225 and 226 in your textbook to do what's called a chi-square test for independence. And here you're taking 2 categorical variables, in this case education level and smoking, and we're going to be using the recoded version of the education level variable, and the same smoke variable that we just used in the survey.save file. Now this time around, if you're following the directions in your text for the chi-square test for independence, you go to analyze, and this is kind of a circuitous route to get to a non-parametric test, but you start with descriptives, and you go down to what's called crosstabs, because essentially what you're producing is a cross tabulation. And I'll kind of show you in the table when it's generated in the output how that works. So our 2 variables are education level, and if you go down here, this is a recoded variable, and it'll be listed as education recoded, educrec. You need to put that in the rows box, and then smoking, do you smoke, in the columns box. Now, if you click on the statistics button, you need to tick the box for chi-square, you tick the box for phi and Kramer's V, and then you click continue. Then you click on the cells button. In the counts box, you make sure it has a tick for observed. In the percentage section, or the percentage box, you want to click on the row box. In the residuals section, you want to click on adjusted standardized. And then you're ready to go. So you click on continue and OK. Now what you see here in the cross tabulation, so you're going to tabulate how many in each of these cells. So people who didn't complete high school, how many smoke, how many don't smoke. Those who completed high school, how many smoke, how many don't smoke. Some additional training, how many smoke, how many don't smoke, and so on. So that's across 2 variables tabulation of frequencies. Now the test for independence, and here's my version of why they call it that. are these two qualitative variables independent or do they co-vary? That's the question. So you're testing whether or not they are independent of one another. In the statistical tests, what you're going to look at, there's the Pearson chi-square test. Here's the value of the test. Here are the degrees of freedom. And then the significance value. Now remember, we usually by convention, we are going to use a significance test threshold of 0.05. And this test is not below this significance value, or p-value is not below 0.05, it's 0.071. Now occasionally you'll find authors who will write something like, well, it didn't meet the level of 0.05, it was marginally significant at 0.07. Now many researchers think that that's a really dubious kind of thing to say. You could, to a reader, if you were writing about this finding, say, it's possible with further research that this pattern could be verified, but basically it's not significant, so you really shouldn't go any farther than that. All right, now I asked you to then write a sentence describing this result, and again, on page 229, in a little gray box about just short of halfway down the page, it gives you an example of how to write about a finding like this. So when I wrote the sentence, I wrote, the chi-square test for independence revealed a non-significant association between recorded education level and whether or not participants were smokers, comma, chi-square, and then you report the degrees of freedom is 4, and it's 4 because you've got 1, 2, 3, 4, 5 levels of education, so it's 4. And the N is 436, that's the number of valid cases. The chi-square value is the Pearson chi-square value of 8.63, and the p-value is 0.07. And notice that with the p-value, you're going to use, if you report the actual value, you're going to use an equal sign. You could, though, report it as greater than 0.05 and use the greater than sign. Since SPSS is giving you the actual value, I tend to report the actual value of p. And then you add an additional piece of information, the phi value, which in this case is 0.14. And that concludes our tutorial for the homework for Chapter 16. As I said, in your chapter there are lots of other kinds of nonparametric statistics. I'm going to, I made an executive decision to just have you focus on the tests that you're most likely to be running. But note that if you find yourself in a situation where you need a non-parametric alternative, you can look back to that chapter where you were asked to, make some decisions about which test to use, and there's a chart that shows you what are the non-parametric options for your particular test situation. Remember that you can always go to that and you can look up how to run the various types of non-parametric tests for your specific situation by using your survival manual.